Right, welcome back to this lesson. This is Mr. Long, your maths teacher today. Now, this video is created for my P5 students in 2025 to do for their long weekend homework. They are doing just 5 questions from this paper. They finished the earlier portions. Okay, it's paper 2 from the Tulakura Primary School practice paper set 1. Now, I promise you to provide some homework support for you. I will not give you the answers, but I'll guide you along and help you to explain things. Okay? Hope this helped you. Remember, your exam preparation is not just doing these 5 questions. You should go back to the previously marked work, cover the questions up and try them again. Right, let's start with question 11. Now, Ben made a sculpture by joining 3 identical iron bars together as shown. Okay, find the length of the shaded part of the iron bar. In case you can't see clearly, this part is the shaded part. Now, how do we do this? Now, you have a few important clues. The first one is they are identical iron bars. That tells you their length, each of the length is the same. Each of the length is at 26.5 centimeters. That's the first clue. So to find the length of the shaded part, so what can you do? Now, let me give you an illustration using some physical manipulatives. The good thing about doing homework at home is you can do things like what I'm doing right now. So I use this post-it. I didn't cut to the exact same size, but they are all it's not the same size as the diagram, but they are all same in length. Okay, these 3 post-its will represent the 3 iron bars. Now, if I put them side by side, like this, you can figure out what's the total length. 26.5 times 3. Now, let me just rewind a little bit. I don't want my students to be looking at numbers and just trying to multiply or subtract or divide them, because you have a calculator, right? And you may think, I just press some numbers and get it out. No. First step is always to try to understand this. In the exam, you don't have the benefit of using paper like what I'm doing. You have to imagine it. But if you're doing it at home, of course, you can use these things to help you to understand it. In the exam, use your imagination. Okay, let's come back to this. Alright, 3 identical bars arranged in a certain way. Right, of course, they're not arranged in this manner. They're arranged in this way. Alright, now, if this is the case, you see, start and end, if I end here and start at the same point, total length is still 26.5 times 3, right? The difference between what I've done here and what is printed is that there's some overlap. Notice the overlap. Now, how to understand this overlapping? Now, take a look at what I'm doing here. Look at, you see some fold lines? I folded the paper. Look at the fold section number 1, which is this part, number 1, and this part number 1. If I go in and this part overlaps, do you think that now it's like the length here from this part to this part, right? It's of course shorter than the original length. In other words, what is the length from this part to this part? It's 26.5 minus away this overlap part. It has become shorter by this part. Same thing for the length of the pink color paper. At first it was 26.5, but if you were to measure only up to the point where I folded, it means that this has shortened by this much. That is the overlap portion. So we're going by this amount. This means that the top sheet of paper, or the top iron bar, has its length reduced by the overlap portion. So in the diagram, this overlap portion here is 7.8 centimeter. This part is 7.8 centimeter. That means that if I were to do this on my paper, this part here up to here is at 7.8 centimeter. Okay? Next, same idea for this portion. if I put it end to end, of course, the length is the same. But if I overlap it, if you can, not sure you can see the folded portion here and the folded portion here. If this part were to overlap, that means that this yellow strip has this portion shortened by this overlap portion. So according to the diagram, the overlap portion here is shortened by 2.3. So here up to this part is shortened by 2.3 centimeter. So the whole length at first was 26.5. But if we look at only the shaded part, which is the part that I've now highlighted inside here, this highlighted portion is definitely shorter than 26.5. How much shorter? It's shortened by this side that has overlap on the left hand side, and this part has overlap on the right hand side. Alright, so this is my help for you to understand how to find the shape of the part in the middle. If you're not sure, re-watch this explanation again. Now, to give you further help, I've dotted line this part. This part is the start of the yellow strip of paper. Okay, like this is the start of the yellow strip. This is the end of the yellow strip of paper. And of course, the entire length at first is 26.5 centimeter. And this is the overlap portion. This is the other overlap portion. Overlap means cover. Right now, find out what is this part in the middle. Right? So you will cut. This is another way to understand this. This is the other way to understand this. Okay? Now do this yourself. Next thing, what is the length of the sculpture? Sculpture is just referring to this thing by itself, right? This whole thing. So what's the length? It's definitely not 26.5 plus 26.5 plus 26.5 because there is this overlap portion. So it's not that long, okay? But from this point to this point, yes, this part is 26.5. Now you have the shaded part here that you found in part A. This part is 26.5 centimeter. This part is the part A answer. And then this last part here, alright, is also 26.5. So what's the length of the sculpture? You tell me. Use these three numbers. Right, and what should you do with these three numbers to find the total length of this sculpture? Okay, now let's go on to question 12. The table below shows the parking charges at a car park. So, understand the table. So, this is in the morning, 8 o'clock until evening, 6 p.m. First 1 hour, you park the car in the first 1 hour, is at $2.20. You can buy at any time. Let's say you can buy at 1 o'clock. 1 to 2 o'clock is the first 1 hour. You can park at 10 o'clock in the morning. 10 to 11 o'clock is the first 1 hour. If you need to park for longer than 1 hour, every additional minutes or part thereof means if you park less than 30 minutes, right, it's 1 hour, $1.50. Every hour part thereof, but if you park at night from 6 p.m. in the evening up to midnight, then up to almost before 8 o'clock the following morning, it is at $2 per hour, or even if you park less than 1 hour, it's also $2. Now, Danny parked his car from 2:15 p.m. to 5:30 p.m. So in other words, this timing is for here in this part. So let's draw a line, a timeline, and put in a timer. So this part is starts at 2:15 p.m. and it ends at 5:30 p.m. Now, don't be stingy. Use more space to draw it out. So you can space out, you can write in the numbers, dollars clearly. Now, let's talk about the first 1 hour. So, 1 hour. After 1 hour, what's the time? 3:15 p.m. Then every additional 30 minutes, let's add every additional 30 minutes. So 30 minutes later, that will be 3:45. 30 minutes later, this will be 4:15. You see, that's why I meant we need to have more space. So I need more space. So I'm going to cancel this because I didn't draw my timeline long enough. 30 minutes later is 4:45 p.m. 30 minutes later, there's 5:15 p.m. Then there is up to 5:30 p.m. So this part is at 30 minutes. 30 minutes. Notice 30 m is 30 meters. 30 min is 30 minutes. 30 minutes. 30 minutes. And this is not 30 minutes. This is a part thereof, 15 minutes. So how much would Danny need to pay for the first 1 hour? You look at this. How much must he pay for every additional 30 minutes? Look at this. And how about the part thereof? Look at this. Then show your sums, how you're going to do the working, and express your answer clearly and write the answer in the empty space provided. Next part. Evan parked his car at the car park. I'm just going to fold it up so you can look at the table together with this. Now Evan is a different person. Now Evan parked his car 4:50 p.m. during this time. When he left the car park, he paid $9.70. Well, that's a lot of money. So what was the latest possible time he left the car park? So again, we need a timeline. Okay, let's start with his 4:50 p.m. was when he first parked the car. First 1 hour, after 1 hour, that will be at 5:50 p.m. Is it still within this range? Yes, it's still within this range. So for this amount, at this time, so he need to pay $2.20 here. Now be very careful here because 5:50 to 6 p.m. is the part thereof. So 5:50 to 6 p.m. is that part thereof, that 10 minutes here. And for that 10 minutes, he should be paying this much, $1.50. Okay. Next. Now, from 6 p.m. to 7:59, now we start the calculation differently. Now, calculation is every hour, no more half an hour, every 1 hour, so 6 p.m. to 7 p.m. This time here is 1 hour. During this time, Danny need to pay $2. I need to keep track on your calculator. So how much has he paid already? 220 plus 150 is 370 plus is 570. You need to reach 970. Okay? Another 1 hour, 8 p.m. Another $2. So you're now going to figure out what is the final time, the latest time he could have left the car park. Such that you add up all the numbers on top, you get $9.70. Now, latest time means the latest possible, not the earliest possible. So, this is not complete, boys and girls. There's still something else to add because if I add these few dollars, 2 plus 2, 4, 4 plus this is 550, 6, 7, 70. Okay, I haven't finished. We have not added up to 970 yet. We need to carry on some more here. Okay, then you can find out what is the latest possible time you left the car park. Okay, now let's go to the next question after you're done with this. ABC is an isosceles triangle. Isosceles refers to, let's go a quick revision, a triangle with two equal sides and there are two equal angles. Now, PBQ is a right angle triangle. So where's ABC? ABC is ABC, right? This is a triangle. So these are the two toothpicks to tell you that this angle that I'm coloring in red right now, this part, this angle is equals to this angle. Be very careful, there's so many angles inside. So they tell you this one is 68. So you already know, sorry, it's up to here. I miss out this portion. This whole thing here is 68. So this is 68. I tell you this part here is also 68. You may write down 68 degrees here. Alright, we have used this clue. Next one, PBQ is a right angle triangle. So PBQ here. This is the right angle. And this right angle triangle, they tell you that AC, they didn't tell us anything else. Now, so remember in a triangle, right? The property, the sum of angles in a triangle is 180 degrees. You know, this angle here is already 90. This angle here is 34. So if you can find what is this angle, which is this one you can find. This angle. This angle is inside this triangle, right? As you can see, this triangle is a triangle PBQ. So this angle 90 degrees plus 34 plus this angle gives you 180. So you can find out what is this if you need to. The next one, they tell you AC equals to AB. Where is AC? AC is this line. Now this line is AC. This line here is AC. See, A and C. And AB, of course, okay, this one we definitely know because we know it's an isosceles triangle. So these two lines are equal. Alright, now first one, find angle ABP. For those who still have difficulty looking for this, first look at the center letter B. This angle is at point B, here. And this angle is formed by between the lines AB. AB is this line. And BP. So BP is this line. See, B is here, P is here. So therefore, you can tell that this angle is not 68, because 68 is all the way up to this part of the red. Okay, so you are looking for this portion only. This portion only. So in other words, you're looking for this. ABP is this one, this part in blue. This big angle. Now think, how should you do this? Okay, now we can use a few things to help us, right? Let's recap. We learned about sum of angles in a triangle is 180. Learn angle on a straight line. Alright, add up to 180. No matter how many of these you add, you get 180. Angles about a point is 360. Then about vertically opposite angles, two angles are equal. Right, so here, let's see. Angle ABP is found inside this triangle. See, I'm covering the parts that we don't need. Now, exam you cannot have paper inside, but you can have a big eraser that you can cover parts of it, or use a ruler, like a ruler to cover the parts that you don't need to see. So now you only see a triangle ADB. You have this angle 85. If you use this idea of sum of angle in a triangle, I know that if I can find out what is this angle, this one, I can use 180 minus 85 minus this, and I'll get the answer that I need. But I don't have this. So what should I do? Now, let's take a look at a different triangle now. Let's take a look at this triangle. Remember, you have an isosceles triangle. In this isosceles triangle, you have these two angles are the same, right? How can you find this angle? So let's recap. I give you a different isosceles triangle. For example, if you know this angle, let's say is 40 degrees, and this isosceles, what is this angle? also 40 degrees. Then how can you find this angle on top? You use 180 minus away 40, minus away 40, and you will have 100 degrees. So this is 100 degrees. Double check, 100 plus 40 plus 40, you get 180. This is how you find this angle knowing these two. Okay? So, this is my clue to you. Step 1, find this. Okay, step 1, using the 68 degrees here and the 68 degrees here. Once you have found this angle, step 2, now you use sum of angles in a triangle. You have this angle, you have 85, 180 degrees minus these two, you get the answer that you need, angle ABP. Okay, I've basically helped you with the steps. Now you just need to put it on paper. Next, you're supposed to find angle CBQ. CBQ. Let me just fold this up. Where is CBQ? So we look at the angle, the letter in the middle first, which is B. So it's here. It's formed between the line CB. So CB, where is CB? CB is this line. Okay, and BQ. So BQ, where is Q? Oh, sorry. CB is this line. See, yeah? CB, and between BQ. So BQ is this line. Okay, this part here, right? BQ. Alright, if I know what is this angle, I can find this. 180 degrees minus 90 minus this angle, I get this. But I don't know if I can get this angle. What's another way that we can try to get angle CBQ, which is this part here that I'm shading. This angle CBQ, this part in blue that I'm shading. Think for a while. Okay, now you notice that this is a 3-mark question, so you're going to take a little while to get there. So I go back to this part again. I need to know, let's work backwards. If I have this, I can find what we need to find, right? This angle CBQ. But I don't have this. So let me think, how can I get this? Then now I see there's a straight line here. 180 degrees minus 68 minus this angle, I will get this. But I also don't have this angle. Okay? But I know if I have this angle here, the one I'm pointing to right now, this part, I can get this blue angle. Let's see. Now, this is a triangle here, right? Can you see a triangle? If I know what is this angle, I can use 180 degrees minus 34 minus this to give me this angle. But I don't know what is this. I don't know what is this. But lastly, now you can see vertically opposite angle. Can you see the vertically opposite angles here? You can see two lines cross like this, right? This angle here is 85. Step by step. So now you can tell me what is this. This is 85 degrees as well. So help you the first thing. So write down angle. This is angle PDC. Angle PDC is equal to 85 degrees. So that's vertically opposite angle. That's the first step. Then, second step, I'm gonna write the number beside. I will not do for you. Now this is your first step done. Now we need to find this angle. I'll call this angle number 1 here. I'll put number 1. So you have this step here now, which is number 1. Okay. You need to find this one. To find this, you use 180 minus 34 minus 85. Okay, and you get an answer. I won't tell you what the answer is. You have a calculator, you can work it out yourself. Then you have angle number 1. Next one. There's a straight line here. See a straight line, right? It's a straight line. It's a straight line, huh? We found angle number 1 already. Now I want to find angle number 2. Angle number 2 is this part. So angle number 2 there, we use 180 degrees, minus away this 68, minus away angle number 1 which you found, which is the angle here, right down here, and you get this answer, which is your angle number 2 here. Finally, now we have angle number 2 already. We have your sum of angle in a triangle. Now you can find the final answer, which is angle CBQ. There, angle CBQ. Now, sum of angle in a triangle, 180 minus away this angle number 2, which you already found. Then minus away 90 degrees. You will get your answer. So I help you to find out. I help you with the steps, okay? And you now need to fill it in the blanks. If you're not sure, just listen to the explanation again. Pause this, rewind to the part, and listen to how I work backwards from needing this to looking for this to finding this. Okay? 2 more questions. Question 14. Mr. Goh had some money. He spent 1/5 of his money on 6 identical notebooks. He spent 1/3 of his remaining money on another 2 identical notebooks and 3 identical bags. Bought so many things. What fraction of his money was spent buying a notebook? Think for a while. I think it's easier if you were to draw out a model, and I'm going to show you how to draw it, and you will draw together with me. Remember, don't be stingy with your amount of space that you have. Okay, so let's get started. Now I'm going to use the whole length of my ruler, 15 cm of it. I'm going to start from here. First is he spent 5 parts. I will first draw 5 equal parts, so I'm going to draw one straight line here. 15 divided by 3, by 5 I get 3, right? So therefore each part here I go with 3 cm. 3, 6, 9, 12, 15. Okay, so I'm going to draw my model. Right, follow my dimensions here, 15 cm. Then each part here you divide into 3 cm. So 1 out of 5, this is 1 out of 5. So 1 out of 5, this is the 1 out of 5, this part. This part is a 6 notebook. 6 notebook. Then where is the remaining money? The remaining money is here. This part is the remainder. Remainder. Write it down, please. Remainder. And he bought 2 identical notebooks and 3 identical bags here. He spent all the money, okay? Now, but here he said he spent 1/3. He didn't spend all the money. He spent 1/3 of this. Now, I have a bit of difficulty here. He said the remaining money is then 1/3, right? But if you notice, I'm going to cover this part first. 1/3. But there are 4 parts here. How do I cut into 1/3 from 4 parts? If it's 3 parts, 1/3 is simple, just this. But it's 4 parts, you know. How do I get my 1/3? Think about it. Now, you can think about it in 2 ways. First way is this. Notice the denominator here is 3, the denominator here is 5. So think, what is a number, a multiple of that is a common multiple of 3 and 5? 3, 6, 9, 12, 15, 5, 10, 15. 15 is a common multiple of both numbers. So what if I can cut the parts here, right? Cut this whole model into 15 parts. That means that each small part I cut into 3. 3, 6, 9, 12, 15. If I do that, okay, bear with me. So I'm going to just cut in dotted lines now. And see if this helps me or not. Okay, of the remainder, he says he spent 1/3. Now, how many parts do you see here? Equal parts. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 1/3 of 12 is actually 4 parts. So this tells me that these 4 parts, from this part all the way up to here, 4 parts, right? He's spending on 2 notebooks, same as this kind, plus 3 bags. It's one way to understand this model. Another way is this. Now, I can see 1/3 in this way. So, he spent 1/3 of the money. Remember I said he already spent up. This is spent already, gone, right? This part is gone. No more spend this part. 1/5 on the 6 notebooks, gone. Okay, of the remainder he spent 1/3. How do I get 1/3 from 4 parts? Well, I look at 1/3 first, as in I ignore this, okay? I ignore this. So I just imagine, oh, this is 1/3. Okay? I know it's not 1/3 yet, but let's imagine that that is 1/3. Cannot? But you know that is not 1/3, correct? That's not 1/3. That is not enough to make 1/3. This 1/3. 1/3 of these 3 parts. Then, from this extra part I covered, get another 1/3 out. There, get this 1/3 from this remaining part. Move it here. There, this is your amount that was spent on the 2 notebooks and 3 bags. That's another way you can understand this. So I've used a clue 1/5, 1/3, 2 identical notebooks and 3 identical bags, 6 identical notebooks. So what fraction of his money was spent on buying a notebook? A notebook. Notice here, this is 6 notebooks, right? 6 notebooks. These 6 notebooks were spent like this. So, but there are only 3 parts. Now, how can I cut into equal parts to get 6? Let's cut some more. So this is actually 1 notebook, right? 1 notebook. The second notebook, third notebook, fourth notebook, fifth notebook, sixth notebook. Sixth notebook. So what fraction was spent on buying a notebook? I know it is this black one. But how to express this in terms of fraction? Now I'll give you 2 ways to do it. One way is, this is 1 out of 6, right? This is 1/6. But this 1/6 of what? What is this part? This big part is 1 out of 1, 2, 3, 4, 5. This is 1/6 of 1/5. That's 1/30th. This is the first way. The second way using a model is this. Remember, I cut everyone into a smaller part. Let's cut some more. That's why I need to draw the model bigger, so you have space to do this. Let's count how many equal parts are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. 1 out of 30. These are 2 ways you can think about to do this question. Next one. What fraction of the money was spent buying a bag? I'm going to just fold this paper up so we can look at the model and the question together. What fraction was spent on a bag? Think about it. Using a model is very simple. Remember, one black part here is 1 notebook, right? 1 notebook, 1 notebook, 1 notebook, 1 notebook, 6 notebook. So here, 2 notebooks will be here. 1 notebook, 2 notebooks. The 2 notebooks will be these 2 black small parts. What about the 3 bags? How many small parts make up the 3 bags? 1, 2, 3, 4, 5, 6. So we know to buy 3 bags, you need to spend 6. To buy 3 bags, you need to, this person, Mr. Goh, need to buy 6 out of 30. Total is 30 small parts, right? 6 out of 30 to buy 3 bags. This is 3 bags. It's 3 out of 30. But we're looking for what fraction was spent by a bag. So to get to 1 bag, 3 divided by 3, I get 1. So here I'll have my 6 divided by 3. So that means 6 out of 30 divided by 3. You do a keep, change, flip, keep. Change, flip. Then simplify. 3 divided by 3 is 1. 6 divided by 3 is 2. 2 divided by 30. Then simplify further. 2 divided by 2 is 1. 30 divided by 2 is 15. And the answer is 115. Next, what is the greatest number of bags Mr. Goh could buy if he spent all of his money on the bags at first? So let's go back to our model again. That's why having a model really helps you to check your work as well as understand the question. What is the greatest number of bags? Now, let's say if Mr. Goh didn't buy any notebooks, if he only buy bags, how many bags can he buy? Now, we already figured out, right? To buy 1 bag, he needs to spend 1/15 of his money. 1/15. 1/15 is the same as 2 out of 30. So, in other words, to buy 1 bag, he needs to use 2 parts here. This plus this equals to 1 bag. So, how many bags can he buy if he used all the money just to buy bags? So, you can do it by just counting, right? The 30 parts all together, right? So, this is 1 bag, 2 bags, 3 bags. Every 2 parts is 1 bag. 4 bags, 5 bags, 6 bags, 7 bags, 8 bags, 9 bags, 10 bags, 11 bags, 12, 13, 14, 15 bags. Or you just do this. There are 30 equal parts there. 30 small equal parts. Every 2 parts is equivalent to the money spent on buying 1 bag. So 30 divided by 2, you will have 15 bags. Okay, so that's your answer here, 15. Now let's go to the last question. Sophia sold some cakes and Tiffany sold some pies in a school fun fair. Some pies, some cakes. Sophia sold cakes, Tiffany sold pies. They received a total of $308 from selling cakes and pies. Tiffany received less money than Sophia, $196 less. Now, how much did Sophia receive from selling the cakes? Think about this first. First step, draw the model. That is to simplify. So take a ruler and draw together with me. So we have Sophia and Tiffany. Tiffany, interesting spelling here. Now who received more money? Who received less? Tiffany received less. So Tiffany's model should be shorter than Sophia. So Sophia's model should be longer than Tiffany. So remember, don't be stingy. You can draw longer ones. Now I'm using pen to make sure it's clearer on the video, but you don't use pen to draw model, please. Okay, use pencil. Okay. Now if I cover this part, you can tell the top and bottom is the same, equal. So you want to see more than, it must be on this side. This is the more than part. So the 196 is here. Tiffany received 196 less than Sophia. Okay, so I've used this number. Where is 308 go? This is the total, right? So 308 is here. So how to find out Sophia's money? So I need to know what is this number. Then I add to 196. So step 1 is you need to remove away 196. Then you have two equal parts. So first step is 308 minus 196. That's the idea of removing, right? You get an answer. This answer represents two of these. Right? Now, but you don't want two of them. You only want one of them. You only want one of them. So the number on top, number below, these two represent whatever answer you get here. Then you need to divide by 2. This number here, you need to divide by 2. So divide 2 means get rid of this. I'm left with this number. Okay. Now this number is a pink one here. Now Sophia's money would be this pink part plus 196. Okay. Plus 196. So use this idea here, this explanation, to help you to answer part A. Next, let's go to part B. Now, Sophia sold 3 times as many cakes as Tiffany sold 4 pies. The language can be confusing sometimes. Sophia sold 3 times as many cakes as Tiffany sold 4 pies. In other words, if Sophia sold 1 pie, Tiffany sold 3 cakes. If Tiffany sold 2 pies, Sophia will have sold 3 times 2, 6 cakes. Sophia's cake cost $2 more than Tiffany's pie. So how many cakes did Sophia sell? Think about this. Right, I'll go back up here. By now, you should have gotten part A. Let's double check if your part A is correct. Because part B is really much harder. So I think it's easier to have this number here before you can work on part B, and I'll guide you through part B. So 308 minus 196, you have 112. 112 divided by 2, you have 56. 56 plus 196, you would have $252. So $252, right, would be the amount of money Sophia received from selling cakes. Okay, now that we have that, I'm going to just move this up. Okay. Now, Sophia received 3 times as many cakes as Tiffany sold 4 pies. Now, let's try to understand this. So, let's go back to the model. I'm going to draw a new one. Sophia, she received 252, right? Pardon me, extra here, okay? $252. We found that in part A. Ignore this part, please. Now, we also know, we can now try to find out how much did Tiffany get. Okay, now Tiffany's amount of money, how much did Tiffany spend? Well, we know she spent less by 196, right? Less by 196. So 252 minus 196, you have the amount that Tiffany actually Tiffany made, she got from selling. That will be $56. Alright, that will be this part, $56. Now, Tiffany sold 3 times as many cakes as Sophia sold 3 times as many cakes as Tiffany. So 3 times. Let's divide the amount of money that Sophia got by 3. So 252 divided by 3, we will have $84. Okay, $84. I'll pause for a while. Now here's the tricky part, right? Now, pardon me, I'm going to redraw the model again because this is not the best looking model. So for Sophia, 3 parts now. This part is 84. Now, Tiffany's part, right, is 196 less than Sophia. So this part we found out is 56. Now, how to find out how many cakes did Sophia sell? So, let's take a look at only this portion here. Only this portion, this part. Compare just this 1 unit here and this 1 unit here. So let's find out what's the difference. 84 minus 56, I'll have 28. What does this 28 means? Now this 84 is like this. Alright, this whole bar in yellow here is this $84. And this 56 is this red bar here. Okay, or I put it this way, this is Sophia's one, and this is Tiffany's. Now you can see that Sophia's one is thicker than Tiffany. Why is it thicker? The top part here is the same, right? The extra part is this part, all these $2. Now how many $2 are there? Because you know that Sophia's cake costs $2 more than Tiffany's pie. $2 more. So I need to find out what is this entire part. Then I divide by 2. Then I will know how many cakes did Sophia sell in 1 unit. So I use 28 divided by $2. That will be 14. As I can see here, I divide by $2. Right, I have 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are 14 cakes here. There are 14 pies here. 14 cakes, 14 pies. And each cake is $2 more than the pie. You see? Each cake is $2 more than the pie. So they fit that condition. Each cake is $2 more than the pie. As you can see here, right? $2 is longer than the pie part. Alright, 14 cakes. Now, how many cakes were sold? This 14 cakes is in 1 unit. There are 3 units there. So 14 times 3 equals to 42 cakes. Alright, this is not an easy question. So this one, I worked through with you all the way to the end. Try our best to understand this again by listening to this video again. Alright, that's all for this lesson. I hope this helped you to understand how to do these 5 questions. Take care, all the best, see you on Tuesday.